Hey there, science fans. Today we're diving into the fascinating world of the periodic table. It's like a giant puzzle where each piece represents a different element. Elements are the basic building blocks of everything around us, from the air we breathe to the devices we use. The periodic table is not just a random chart, it's a carefully organized system. It arranges all the known elements based on their atomic structure and properties. This arrangement helps us understand the relationships between different elements and predict their behavior. Think of it like organizing your bookshelf. You wouldn't just toss your books in randomly, right? You might group them by genre, author, or size. Similarly, the periodic table groups elements with similar properties together. This makes it easier to study and understand their characteristics. So buckle up as we embark on an exciting journey to explore the wonders of the periodic table. Get ready to unlock the secrets of the elements and ace your GE 2025 exam. Let's start by understanding how the periodic table is structured. It's like a grid with rows and columns. The rows are called periods and the columns are called groups. Each period represents a different energy level. Think of energy levels as floors in a building. Elements in the same period have the same number of electron shells. For example, elements in period 2 like lithium and neon have 2 electron shells. Groups, on the other hand, represent families of elements with similar chemical properties. Elements in the same group have the same number of valence electrons. Valence electrons are the electrons in the outermost shell, and they determine how an element reacts with others. For instance, group 1, the alkali metals, all have one valence electron. This makes them highly reactive as they readily lose that electron to form positive ions. On the other hand, group 18, the noble gases, have a full outer shell of electrons. This makes them very stable and unreactive. Understanding the arrangement of elements in periods and groups is crucial to grasping the periodic trends we'll discuss next. The modern periodic law states that the physical and chemical properties of elements are a periodic function of their atomic numbers. This means that as the atomic number increases, the properties of elements repeat in a predictable pattern. The atomic number represents the number of protons in an atom's nucleus, which defines the element. The periodic law helps us predict how an element might behave based on its position on the table. For example, if we know the properties of lithium, we can make predictions about the properties of sodium, potassium, and other alkali metals in the same group. This predictive power makes the periodic table an invaluable tool for chemists and scientists. The periodic law is a fundamental concept in chemistry. It's like having a cheat sheet for understanding the elements. Now, let's talk about periodic trends. These are patterns in the properties of elements that change predictably as we move across a period or down a group. Understanding these trends is essential for predicting element behavior and reactivity. One important trend is atomic radius, which is the size of an atom. As we move across a period, atomic radius generally decreases. This is because the increasing number of protons in the nucleus attracts the electrons more strongly, pulling them closer. Ionization energy is another key trend. It's the energy required to remove an electron from an atom. Ionization energy generally increases across a period and decreases down a group. This is because it's harder to remove an electron from a smaller atom with a stronger pull from the nucleus. Electronegativity is a measure of an atom's ability to attract electrons in a chemical bond. It generally increases across a period and decreases down a group. Finally, electron affinity is the energy change that occurs when an electron is added to a neutral atom. It also shows periodic trends. By understanding these trends, we can predict how easily an element will lose or gain electrons, which determines its reactivity. Section 5. Alkali metals, the reactive champions. Let's meet some of the key players on the periodic table, starting with the alkali metals. These elements occupy group 1 and are known for their high reactivity. Alkali metals have only one valence electron, which they readily lose to form positive ions with a +1 charge. This makes them highly reactive, especially with water. In fact, their reactions with water are quite explosive, producing hydrogen gas and an alkaline solution. Because of their reactivity, alkali metals are not found in their pure form in nature. They're always found combined with other elements in compounds. Some common examples include sodium chloride, which is table salt, and potassium chloride, which is used in fertilizers. These metals are soft and silvery white in appearance. They have low melting and boiling points compared to other metals. They are also good conductors of heat and electricity. Their reactivity makes them essential components in various industrial and chemical processes. Section 6, halogens, the salt formers. Now let's move on to group 17, the halogens. These elements are highly reactive nonmetals, known for their ability to form salts when they react with metals. Halogens have 7 valence electrons, meaning they only need one more to achieve a stable full outer shell. They readily gain this electron by reacting with metals, forming negative ions with a -1 charge. This is why they are found in many salts, such as sodium chloride and potassium bromide. Halogens exist in all 3 states of matter at room temperature. Fluorine and chlorine are gases, bromine is a liquid, and iodine is a solid. They have distinctive colors. Fluorine is pale yellow, chlorine is greenish yellow, bromine is reddish brown, and iodine is violet. These elements are highly reactive, especially fluorine, which is the most electronegative element on the periodic table. Their reactivity makes them useful in various applications, such as disinfectants, water purification, and the production of plastics. Section 7. Noble gases, the lone wolves. Last but not least, let's meet the noble gases, residing in Group 18. These elements are known for their lack of reactivity, often referred to as inert gases. Noble gases have a full outer shell of electrons, making them extremely stable and unreactive. They don't readily form bonds with other elements, preferring to exist in their elemental form. This is why they are found as monatomic gases in nature. They're colorless, odorless, and tasteless gases at room temperature. Helium, the lightest noble gas, is known for its low density and use in balloons. Neon is used in advertising signs for its bright red-orange glow when electrically charged. Argon, the most abundant noble gas in the Earth's atmosphere, is used in various industrial processes. While they are generally unreactive, some noble gases like xenon can form compounds under specific conditions. However, these compounds are rare and require special techniques to synthesize. Section 8. Special cases: lanthanides, actinides, and transition metals. Besides the main groups, the periodic table also includes the lanthanides and actinides, often shown separately at the bottom. The lanthanides, also called rare earth elements, are a group of 15 metallic elements with atomic numbers from 57 lanthanum to 71 lutetium. They are silvery white metals that tarnish readily in air. The actinides are a group of 15 metallic elements with atomic numbers from 89 actinium to 103 lawrencium. They're all radioactive, and many are synthetically produced in nuclear reactors. Both lanthanides and actinides have unique properties and are used in various applications, including lasers, magnets, and nuclear technology. Section 9. Hydrogen, the quirky exception. Hydrogen, the first element on the periodic table, is a bit of a loner. It has 1 proton and 1 electron, making it the simplest and most abundant element in the universe. While it sits in group 1 with the alkali metals, it doesn't quite fit in. Unlike alkali metals, which readily lose their single valence electron, hydrogen can either lose or gain an electron. This gives it unique chemical properties and makes it difficult to classify definitively. Hydrogen is a colorless, odorless, and tasteless gas at room temperature. It is highly flammable and burns with a pale blue flame, producing water. It's a key component of water, organic compounds, and stars. Understanding hydrogen's unique properties is crucial in various fields, including energy production, fuel cells, and astrophysics. Section 10. Transition metals, the colorful chameleons. Nestled between groups 2 and 13 are the transition metals. These elements are known for their variable oxidation states, meaning they can form ions with different charges, leading to a wide range of colorful compounds. Transition metals typically have high melting and boiling points, are good conductors of heat and electricity, and are malleable and ductile, meaning they can be hammered into thin sheets and drawn into wires. They often exhibit catalytic properties, meaning they can speed up chemical reactions without being consumed themselves. This makes them essential components in various industrial processes. Some familiar examples include iron, used in steel production, copper, used in electrical wiring, and gold, prized for its beauty and resistance to corrosion. Section 11. Conquering the periodic table for G 2025. Mastering the periodic table is essential for acing the JE 2025 exam. Understanding the trends and relationships between elements will give you a significant advantage in tackling chemistry questions. Focus on understanding the periodic trends we discussed: atomic radius, ionization energy, electron affinity, and electronegativity. These trends will help you predict element behavior and reactivity. Pay close attention to the properties of key groups: alkali metals, alkaline earth metals, halogens, and noble gases. Knowing their characteristics and reactivity patterns is crucial. Remember the special cases like hydrogen and the transition metals. Understand why they are unique and how their properties differ from the general trends. Practice predicting element properties and reactions based on their position on the periodic table. The more you practice, the more comfortable you'll become with applying these concepts. By mastering the periodic table, you'll be well equipped to tackle the JE 2025 chemistry section with confidence. Good luck, science explorers.